Look at another linear programming problem. So here we have machine A, and they can produce 30 steering wheels per hour at the cost of $8 per hour, while machine B can produce 40 steering wheels per hour at the cost of $12 per hour. The company can either use the machine by itself or machines together at the same time. We want to determine what is the minimum number of hours needed in order to produce 380 steering wheels if the cost must be no more than $108. So I'm going to underline that no more than to help us. Now we're going to define our variables. So we're talking about machine A producing 30 steering wheels per hour, while machine B can produce 40 steering wheels per hour, and both of these are being done at a different cost of running the machine. Our goal is to find the number of hours needed to produce a certain amount of steering wheels in a certain amount of cost. So our variables, what we're looking at, is machine A and machine B. So I'm going to define X equal to machine A, and I'm going to define my Y as machine B. And both of these, I'm going to be looking at the hours that are being spent on both machines. Our objective function is now we need to incorporate, okay, we have our variables defined, now what are we trying to solve for? And we're trying to solve for the minimum number of hours needed to get the 380 steering wheels at a cost that's no more than $108. So from our variables of machine A and machine B, I'm going to have my f of x, y. So again, that's function notation. We're using two variables there, x and y. And so x represents the number of hours for machine A, and it can produce 30 steering wheels per hour. So that is being said as 30x. While machine B can produce 40 steering wheels per hour, so we would say plus 40y. So there we have our variables are defined. We have our objective function. Now we're going to be looking at the constraints. So this is talking about those limitations. What cannot happen? So first off, our simple ones is that it can't be negative. We can't produce negative steering wheels on either machine A or machine B. So we are saying that X has to be greater than or equal to 0 and Y has to be equal or greater than or equal to 0. The next thing is looking at our machines. So our other information that we have is we know that it cost $8 to run machine A and $12 to run machine B, and that's both per hour. We are limited to $108. Let me look at that so you can actually see what I'm writing. So the cost of machine A is $8 per hour, and the cost of machine B is $12 per hour. We can only spend $108. So no more than means that I have to be less than it or equal to it. I can't be greater than it. So $8 per hour for machine A. So that's that 8x. And for machine B, I am $12 an hour, so 12y. Both of these half together has to have a combined cost that is less than or equal to $108. Our other constraint that we're looking at is that we want to produce 380 steering wheels. And so we need to look at, well, how does that occur? Well, we know that machine A can produce 30 steering wheels per hour, so that would represent 30x. Plus, machine B, they can produce 40 steering wheels in 1 hour, and we want to produce 380 steering wheels. And so we're looking at the minimum amount. This is kind of the minimum we want to produce. We need to produce this, but what if it would be awesome if we could produce more than this within staying our budget of that $108? So here we're going to say that this is going to be greater than or equal to 380 because we want to make 380. We could make more than that, but we don't want to make less than that. So these are our constraints that we're going to be using when graphing. So now we're going to look at graphing it. So just like our previous video, we're going to graph by using the x and the y intercepts. So my first function is 8x plus 12y is less than or equal to 108. So I'm going to set up my table for x and y. I'm going to look at what happens when x is 0. So I'm going to plug a 0 in for x, and I'm going to solve for y. So anything times 0 is 0, so I kind of get to cover that up. So I have 12y is less than or equal to 108. I'm going to divide both sides by 12, and I would get that y is less than or equal to 9. So y is 9 when x is 0. Again, you can use a calculator on this to kind of check the work. That's what I did going into it. The next thing is, well, what if y is equal to 0? What is x? So I'm going to plug a 0 in for y. So 8x plus 12 times 0 is less than or equal to 108. So again, anything times 0 is 0. So I just kind of like to just act like this is covered up. So I'm going to have 8x is less than or equal to 108. I'm going to divide 8 by both sides. And so 108 divided by 8 does not go evenly. It goes 13.5 times. So 13.5 is what x equals when y is equal to 0. I'm going to do the same process with my next system. So my next system was 30x plus 40y is greater than or equal to 380. So I'm going to set up my table, and I'm going to evaluate what happens when x is equal to 0. So I'm going to sub in. So I'm going to be looking at 30 times 0 plus 40y, kind of ran out of room, sorry, is greater than or equal to 380. So anything times 0 is 0. So I'm going to be looking at 40y is greater than or equal to 380. To get y by itself, I'm going to divide both sides by 40. So y is greater than or equal to 380 divided by 40 does not go in evenly. You have 9.5 or 9.5. Again, check it on your calculator and you will see. So when x is 0, y is 9.5. So as you can see, this is a little bit different from our previous video, is now that we're not having these nice full numbers, we're actually going to be dealing with some decimals, and that's going to help us when we look at how to graph this. So our last one is, well, what happens when y is equal to 0? So I'm going to have 30x plus 40 times 0 is greater than or equal to 380. So anything times 0 is 0, so I kind of get to cover that up. So I'm going to be looking at 30x is greater than or equal to 380. I'm going to divide both sides by 30. And x will be greater than or equal to, and this time you're going to get 12.6 repeating, or 12 2/3. So I'm going to look at this 12.6 repeating. And I'm putting the repeating decimal in there because, again, it's going to help me for graphing, because I'm going to be looking at graphing based upon these x and y intercepts. Now we're going to be graphing. Again, I just rewrote my intercept tables here to help us out. I've already done the graph. We've defined x as machine A, so here's machine A, and again, we're talking about the hours for machine A. And for y, we define that as machine B, again, as the hours being spent. I looked at my numbers, and so based upon my numbers, they're pretty close together. I have some 9, some 13.5, and 12 and 6 repeating. So I decided to make a scale of 1. You could have chose to do a scale of 2. That is fine. A scale of 5 would have been a little bit too big. So you just kind of look at your numbers and decide in relevance of how big they are, what the scale needs to be. So again, I'm really relatively around less than 20, so I chose to do a scale of 1 for both x and y's. So let's graph our first system. So we're saying when x is 0, y is 9. So here's 0, 0. When x is 0, y is 9. So I'm going to come up and I'm going to plot my point at 9. When y is 0, x is 13.5. So I'm going to go all the way. There's 13 and 14. So 13.5 is roughly in the middle. Now I'm going to take my ruler and I'm going to connect these points. When you graph with using the intercepts, you're only using 2 points. So it's kind of a little bit of a sketch to a point because we don't have maybe something that's going to really help us to find our line in the middle, but it still isn't accurate enough to be doing what we're doing. Next function we have when x is 0, y is 9.5. So when x is 0, y is 9.5, which means that we're going to go up on the y-axis. There's 8, 9, 10, and so 9.5 is between 9 and 10. So I'm going to plot my point there. This one's a little bit trickier because we have 12.6 repeating when y is 0. So when y is 0, there's 10, 11, 12, 13. So I know that 12.5 would be in the middle, and at 12.6 repeating would be just kind of to the right of the middle. So I have my 2 points. I'm going to take my ruler and I'm going to connect them. My other constraints that I had was that x had to be greater than 0. So again, here is my x's. If I would go to the left of it, therefore I would be negative, and I can't be negative. My other constraint was that for y, it has to be greater than or equal to 0. So again, here's looking at my y's. If I was below it, then I would be negative. So again, I'm staying in this first quadrant. So my other lines are represented with the x-axis and the y-axis. Now we need to define those feasible regions. So in order to do that, we need to pick a test point. So again, we need to pick a point that is not on our lines. So we can pick the coordinate 1, 1. Okay? Make it easier on yourself and pick something that we know that we're capable of doing. So we're going to go back to our step 4, and now we're going to be looking at the test points. And we selected 1, 1. So we're going to plug x in and y in, so that's x is equal to 1 and y is equal to 1, into our constraints and see if the statement is true or see if the statement is false. So we're going to be looking at our values of our terms. Okay, so here we're going to put in 1, 1, and so we're going to be looking at 8 times 1 plus 12 times 1. Is that less than or equal to 108? So I'm going to have 8 plus 12. Is that less than 108? And 8 plus 12 would be 20, and 20 is less than 108, so that is a true statement. Okay, now let's see what's happening here. Our next constraint is 30x, so 30 times 1, plus 40 times 1, and we're saying that was greater than or equal to 380. So 30 plus 40, is that greater than 380? So is that 70 is greater than 380? And that would be a false statement. Okay? So now we need to reevaluate. Did we have the correct inequality there? So let's go back to our original problem and see what it's asking us. It says, what is the minimum number of hours needed to produce 380 steering wheels if the cost must be no more than $108? So we were saying that, okay, you need to produce 380, but would it be feasible to produce more than 180? Well, since we want to talk about is that the minimum hours needed, so if it's the minimum number of hours needed to just produce that amount, and we have a constraint of money, is that we might be able to produce 380 or less within that cost of that dollars. So our inequality really shouldn't have been a greater than. It should be a less than or equal to, because we want to produce 380 within that cost of $108. Is this possible? Maybe you can produce more. Maybe you can produce less. We don't know until we have that feasible region and to test our vertices. But this should be a less than, because we need to know the minimum number of hours to just produce 380 and seeing if that is in our time. So if we correct our inequalities, then this should be a less than or equal to, this should be a less than or equal to, this should be a less than or equal to, and yes, 70 is less than or equal to 380, so that is now a true statement. And so we didn't just change it just to make it a true statement, is that we misread the problem. And this occurs, but as we go through the steps, we are able to kind of see and recheck to make sure that we have the correct inequalities. So this was kind of the checkpoint there to make sure that our constraints are correct. Our other constraints are x and y being greater than or equal to 0. So is 1 greater than or equal to 0? That's a true statement. And for y's, yeah, 1 is greater than or equal to 0. So they're all true statements. So therefore 1, 1 satisfies our inequalities or our constraints. So if we go back to graphing, here's 1, 1. Since all of these are true, then we're going to be shading in that region. So we're going to be shading under both the red and the green graph. We're going to be shading above our x-axis, which means that x's are positive as well as our y's, and we're going to be shading to the right of our y-axis, which again, where x's and y's are positive and not negative. So once we have our region met, then we're going to be finding where our vertices are located at. So here we have 0, 0. Okay, here we have our 12.6 repeating. Then we have our 0, 9. The next thing is we have to look at where our graphs cross at. So here's our green graph. And then here's our red graph. So our red graph is below our green, then it's above it. Then our green graph's above, then it's below it. So our intersection occurs where the switch of those graphs are. So these graphs have very similar slopes, so that's why it's kind of, they're really tight within this region. So we're looking kind of where that shift occurs at, and it occurs at 6, 5. So now that we have 1, 2, 3, our 4 vertices, we're going to test them to see which one can maybe produce that minimum amount of hours. So now we're going to record our vertices. So our first vertice that we have here is 0, 0. Our next vertice that we have is 0, 9. Our third vertice is 6, 5. And our final vertice in our feasible region is that 12.6 repeating, so 12 2/3. I'm going to round that to 12.7 and 0. Okay, just because we're going to have this 2/3 of a part, which would be 2/3 of a steering wheel, which is not possible to have. So that kind of gives us a little indication that this one might not work, because again, it's thinking about it as a whole, and just like we had with our fish problems and our people problems, that we can't have a portion of a person or a portion of a fish. So our next step is now we're going to test it in our objective function. So we said our objective function was 30x plus 40y y. Okay, so we're going to be looking at how we can solve for this. So we're going to put in our vertices. So our first one is 0, 0. So again, these are those number of hours, and the outcome is going to be how much the steering wheels that we could produce in using both functions, or maybe just one function or the other function. So this would be 30 times 0 plus 40 times 0. So if we do not use either the function, then the number of steering wheels that could be produced would be 0. So now we're going to look at our next one. So what if we only used machine B? So 0 and 9. So 30 times 0 plus 40 times 9 would be 40 times 9, which could produce 360. Okay, so now we have 360. We want to produce 380, but again, we have to be within that limit of $108. Okay, our next one that we have is 6 and 5. So that would be 6 hours on machine A, and we would have 5 hours on machine B. And so 30 times 6 plus 40 times 5 would produce 380. Okay, let's check our next one. 12.7 and 0. So what if we use our machine A to produce the steering wheels only, and we're going to times it by 12.7, or 12 and 2/3 if we're using our fraction key on our calculator, and we get approximately 381. Okay, so we need to produce 380 steering wheels, and our cost must be no more than $108. So with our graphing of our function, is we had our first one, our red function. This represents kind of that cost of $108. If we're above our red line, this is outside of our feasible region, which means that we would be producing something that would cost more than $108. So anything below the red line would be within that cost. We need to produce 380, which is what our problem told us. So here is the only combination that produced exactly what we needed. So step number 7 is the solution. So we want to determine what is the minimum number of hours it needs to produce this amount of steering wheels. Well, we know that x is equal to 6 and y is equal to 5. So that means that you need 6 hours on machine A, and you would need 5 hours on machine B. This would allow you to produce 380 steering wheels with a cost being $108 or less, and both of these machines would be running simultaneously, or both at the same time. So looking at our vertices, we realized that it was more productive to run the machines together at the same time versus just running machine A or just running machine B.